See the exercise 1.2 here. The first question is given to you. Express the each number as a product of prime factors. The first two numbers are given to you, 140 and 156. They are smaller and you can do it as a homework, and I am taking the third one as an example. 3825 and product of prime numbers you need to express. So let us see the solution of that one here. So here the question is given to you, 3825. So first what you need to do here to do this one, whether the given number 3000, whatever it may be, the number is given, whether it is first prime number is smallest prime number is 2, whether it is divisible by 2 or not, you need to see. Okay, so first here 3825 is not divisible by 3, then next prime number is 3, so whether it is divisible by 3 or not, you have to see here. So it is divisible by 3 ones are 3, and here 8 is there, so 8 is divisible by 3 in 2 times, so 3 2s are 6, and 2 will be left over here. If you get confused here, you can write the small 2 here, and 2 and 2 will become 22. So 2 and 2 will become 22, and 22 means 3 7s are 21, and 1 will be left over. That means you have to divide it. If you feel difficult in doing like this, simply you do the division of the 3825 by 3. So you will get 1275. Again it is divisible by 3. So with the 3 you need to do 425 you got. And 425 is not divisible by 3. It is divisible by 5. So it is divisible by 5. So next prime number after the 3 is 5. So with the 5 you have to divide this. 5 8 is 40 and 2 will be left over. 2 5 25. 5 8 5 is 25. Again it is divisible by 5. 5 17. So the product of prime factors of 3825 is 3 into 3 into 5 into 5 into 7 17. And that can be written as 3 square into 5 square into 17. 3 square into 5 square into 17. The next question is here, fourth one, 5005. So it is divisible by 5 only. It is not divisible by 2 and 3. Better you go in the order. Sir, if I directly take it as a 7, what will happen? You will get the answer. Obviously, you will get the answer. Absolutely, that the answer, whatever you are getting, it is a right answer. So, but better you go in the order. So 1 by 1, it is not divisible by 2, then go for the 3, it is not divisible by 3, then go for the 5, 1s are 5 and 2 zeros as it is 5, and divide by the 7, you are going to get the 143, and divide by the 11, and you are, and here you can observe the one important thing is that 1001 is product of 7 into 11 into 13. This will be useful to you in so many Olympiad exams also. 1001 can be written as a 7 into 11 into 13. So this if you are keeping in the mind, then you can do the so many problems, Olympiad problems also. So here the product of prime factors of the 5005 is 5 into 7 into 11 into 13. The next second question is, the question is asking to you, please concentrate on the book also and read the question very clearly, otherwise you cannot understand directly, don't go for the solutions. So the question is given, find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equal to product of two numbers. So here the question I have chosen as a second question. So first question is very simple numbers, small numbers are given to you, you can do it. 510 and 92, 510 prime factorization I have did it 2 into 3 into 5 into 17 you got, and 92 prime factorization is 2 into 2 into 13 you got. So that can be written as 2 square into 23, which I have written to you here. And here now you can concentrate that whenever you find out HCF, this is a one number prime factorization, this is another number prime factorization. It may be given to you more than 2 numbers, 3 numbers, 4 numbers, 3, 4, 5 numbers also. Like this you need to note down one by one prime factors. After writing prime factors, find out HCF means you need to see that smallest powers of the each common prime factor. So what are the common prime numbers are present here in these two numbers? 2 is a common, and 3 is there in the first prime factorization but not in second, 5 is there in first but not in second, 17 there first not in second, 23 there in second but not in first. Common is only 2. So and what is the smallest power? Here you are having 2 power 1, nothing is there means 1, and here you are having 2 square. So that's why the smallest power is this one. So that should be taken into consider, that is 2. So the 2 is the HCF of these two numbers. And whenever you find out the LCM of these two numbers, the product of the greatest powers of the each prime factor involved in the numbers. Each prime factor means all. 2 is there, you can see here in these two numbers prime factorization. 2 you can see, 3 you can see, 5, 17, 23. For all these numbers, what are the greatest powers are there? 2, if you see that here 2 power 1, here 2 power 2. That means 2 power 2 is the highest power. 2 power 2 should be written. In this 3 is there. But here 3 there, sir, here 3 not is there. Common should not be taken whenever you find out the LCM. So 3, next 5, next 17, next 23. So, sir, only greatest means only one place it is present. So the greatest is nothing but that number itself. So that's why as it is taken into consideration. This is LCM of the given two numbers. And product of LCM and HCF, whenever you see that, this is LCM here, this is LCM, and the HCF is 2 here. HCF is 2. So these two product, if you are seeing here, LCM is 2 square into 3 into 5 into 17 into 23, and HCF is 2. So when you find out the product, you are going to get 46,920. Find the product, and product of the given two numbers is 510 and 92. If you find out their product, 46,920. So both are same answer you are getting here, 46,920, 46,000. That means product of the two numbers will be equal to product of their LCM and HCF. So this is the thing, the question asking to you in the question to prove it. So let us go for the next third question. Third question is asking to you to find out here. Read the third question. Third question is find the LCM and HCF of the following integers by applying the prime factorization method. By applying prime factorization method apply and find out LCM and HCF. And here you need to observe that this rule where product of numbers whenever it is given to you, this is applicable only in case of the two numbers only. So that's why here the rule is given to you also. Here product of HCF of A comma B, A comma B comma C is not given, only A comma B. For three numbers there will be another rule here. Okay, so now see the question, third question here, whatever it is given to you, 12, 15, 21 in this one problem I have taken. So 12 prime factorization is 2 square into 3, 15 prime factorization is 3 into 5, 21 prime factorization is 3 into 7. HCF is nothing but the highest powers of the common prime factors. Common is there in the three numbers, only 3 is there. So that's why 3 highest power is 3 power 1. So that's why 3 is the HCF. And LCM means all the prime numbers, 2 power 2, 3, 5 and 7. So this is third question. And the fourth question is, if you see that, given that HCF of the two numbers, that is 306, and this problem is very, very, very important in examination. Minimum 2 marks you can expect here, or 1 mark also. Sometimes the question may be given to you more number of times repeated question, and everyone practice well. Simple, it is nothing there in this. Don't get panic. So given that HCF of the 306 and 657 is equals to 9, HCF is already given and asking to you to find out their LCM. Here you are not supposed to find out the LCM by any prime factorization method. By applying the rule, LCM into HCF is equals to product of the given two numbers. So LCM into HCF is equals to, HCF is already given 9. So LCM into 9 is equal to 306 into 657. 306 into 657 should be divided by the HCF so that you will get the LCM. So 306 is divisible by 9. 9 ones are 9 3 is 27, and 3 will be left to 36, 9 4 is 36, and here I have found that in a rough column also. See, 657 into 34. You need to do the rough column like this directly. The answers, most of the students I used to find that they used to remember the number. This problem like this, HCF 9 given, answer will get 22,338. Like that most of the students will remember. Don't remember, and do remember that try to solve the problems on your own. Don't take this as it is, don't copy this one. And if you get a doubt, then you open this video or you open the PDF, whatever I am sending to you. But don't copy as it is directly, and go on solving the problems. First you listen and try to understand and see the example problems, so that easily you can go for. And the next one is, fifth question is, prime factorization of the 6 and 6 prime factorization of the the question. Let us read the question. Check 6 power n can end with digit 0. So you can here very clearly you can see that if a number wants to end with 0, so 2 into 5 is 10. If a number having the prime factor 2 and as well as 5 in its prime factors, then only is going to have the 0 at the end. So that's why if you see that 6 prime factorization is 2 into 3, so that's why it never ends with a 0. Okay, so that explanation is given to you. And coming to the sixth one, the question is given that 7 into 11 into this one, 7 into 11 into 13 plus 13, this is a composite number. So you have to prove it. Actually you are not supposed to multiply this product and add 13 and you need to find out. Nothing is required like that. If you see that from these two, 13 you take the common here, 13 is taken common. So if you are taking 13 common, then you can write it as a 13 into 7 into 11 plus 1, 7 into 11 plus 1. This is prime number. This is maybe prime number, may not be prime number. It is not necessary to you to check. If it is a prime number into prime number will become a composite number. If it is a composite number, if this one is a composite number, it can be written as a product of primes by using the fundamental theorem of arithmetic. So that's why if you are having product of prime number and any other number, it may be a composite or a prime number, the product of one prime number, if it is there in the prime factorization, then it is a composite number along with the prime. If along with the prime other than 1, this should not be 1, this should not be 1, it is not equals to 1. If it is equals to 1, then 13 into 1 is 13 prime number. If it is not equals to 1 any other number, then it will be a composite number. In the same way, the next one also you can do it. So this is the sixth problem. And the seventh problem is very easy. Here you can do it as a homework. There is a circular path around the sports field. Sonia takes 18 minutes to drive one round on the field and Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and go on the same direction. After how many minutes will they meet again at the starting point? Here, see here, one round, to complete the one round by the Ravi, he will take the 12 minutes. First round 12 minutes, second round 24, means 12 multiples. You are going on finding the 12 multiples. And here 18, Sonia, whenever you take 18 multiples you will get. And wherever you get the common number, after how many minutes will they meet again? So will they meet again means normally suppose slowly 18 minutes, Sonia is taking 18 minutes. They have started from here. And to reach here 18 minutes she has taken. And Ravi has taken faster. He is taking a round here 12 minutes. He reached here in 12 minutes only. So when he reached here, Sonia may be here. So both the places may be different. And again they will continue like this. And here Ravi comes back again 24. And here to reach Sonia, it takes 36. So what we are doing here, we are taking 18 multiples and 12 multiples. Wherever you get the common number for both, and that time they are going to meet again. So that means what to do, you think here, and if you get it out, then you can ask me. Okay, thank you.